We've achieved the impossible here. We've got data out of an S&M extrusion, Faraday cage in essence, and collected that data, and we've deployed it actively in a store today. So we know that these systems work. Within the Special Nuclear Materials Directorate, we have a number of packages containing special materials that we want to keep safe, secure for long-term storage, and monitoring those and the condition that they're in is of vital importance to us delivering our mission. So the smart sensors work that we're looking at here today enables us to deliver remote wireless sensing of these packages from inside the extrusions without having to put an operator in harm's way.
We've developed these very small disc-like sensors. It sits on the canister. You can imagine there's almost no space inside here for anything functional for electronic components, and yet this sensor can measure pressure, so you can now measure the slightest deflection, a micron scale, so 1/1000th of a millimetre change in canister size. It's now up to 6 times more radiation hard than if we'd just taken standard conventional electronic components. It can measure temperature, it can radio these out for 30 years and more. The communications aspect of this is really impressive. It's very hard, as you make things smaller, to get a powerful signal for the same power that you put into the antenna. And this is a very, very clever antenna that manages to activate the canisters that it sits on, turn them into an antenna, and then it gets a very powerful signal out of these storage compartments. We've, for the first time ever, managed to get these sensors into a real radioactive store. And as we speak, there's data coming out of these stores and we can look at them, and we'll be showing people what's going on inside this store where there's just very limited access. The engineers who developed this have never had access to these radioactive stores. And when it was installed, it just worked first time. I mean, that's brilliant. As an engineer, I'm very proud of that.
We deployed 3 smart sensors on SRP products packages. The trial has been a great success. It's been operating successfully now for 3 months, collecting temperature data on the dummy packages, giving us a data set which we've never had access to before.
Currently we use models to predict how hot those packages are going to get. That's a mixture of thermal models and fluid flow models. The ability to actually validate that data coming in and see the actual temperature of the packages is amazing. We didn't think directly measuring this temperature would be possible, so it's real help for us.
Game changers have been not just great, but actually instrumental in making sure that we as a small company can work very effectively with the very large company that Sellafield is. And it has allowed us to create a very genuine collaboration.
My hope is that this capability is adopted as a business as usual approach. It's ready to go. It just needs the use case and the champion to take this now the next step. Can we deliver this inside a facility? Can we use this on active products? Because the technology is ready.